name is George, and I work for 514, and we're building a open source developer framework for data analytics. It's called Moose. Our founders are Canadian. And this is my first talk. I decided to throw a demo in at the halfway mark, so let's see how it goes. So reasonings behind a developer framework. We've talked to a lot of people, and essentially what it comes down to is they have a small team with just their core engineers, and they reach the point of we want to collect a ton of data and use it, maybe service it to our internal company or our end users. It requires a different skill set and background than maybe some of the team that they currently have. And then they end up running into issues that streaming buffers use, versioning, figuring out how to deal with changing your ingestion points as you change your data models, add, migrate. And it ends up being a really big pain point for them that they weren't necessarily expecting to go out and reach. So when this happens, this has been kind of a theme of a lot of talks. You can always just do Postgres if you're small enough. And if you're small enough, that's fine. They don't make a non-problem. But ideally, you would want to set up something that would scale if you were able to lower the cost of doing something like that. And what is something that scales? Well, also in a lot of talks, it's Kafka, in our case, Red Panda, and from ClickHouse.
Even better.
And got some approval. But again, you need to know these things, you need to have operational know-how. And a lot of who we talk to, they don't, they're a smaller team or they're financially constrained. And if they end up having to go with a use case like Postgres, either they feel the pain or their customers feel the pain. And just because they're resource constrained, we don't think that should be the case. So essentially, the idea is we've got a bunch of infra, and we have abstractions over the infra. It's essentially infrastructure from code, and our primitives are data models, which will set up a table, an ingestion point, and a streaming buffer. Blocks will sort of basically just functions that operate on the database at the beginning, so that's where you set up materializing and start. Streaming functions, which just, if I want to map from one data model to another in between two topics, let's run a function. And then finally, consumption, which is just a request to get in and out. This is a demo that we gave to, I announced a couple days ago, first customer, at 45 gems. Maybe you guys heard of them, Ben. They've got 2,000 gems around the globe. And they've got this project where they've got heart rate monitors that will track you in the gym, get sent to the TV, and then presently gets sent to S3, in which another job will process those and create reports, and then at some point they can view that report within the app. That is like what they were able to get set up, and like COVID really hurts the gym market. Ideally, like so that's what we were able to explain, that in order to get this interactive app that they would love, their customers would love, this is sort of the architecture that you guys need to set up. And if you interface with our things, here's how you do that. So we've got some front-end app that doesn't do anything because all the endpoints are down. And we've got a empty news project, which is just you put a bunch of things in files, file-based convention. It's popular in a handful of frameworks. So I'll just drop these in and go kind of over what they are. So we have AWS upload event. This gets hit to us when we have a lambda function in AWS. When a file is uploaded to S3, we get this event. And this creates a table. If I hit run, sorry. We have a dev server running. When that got dropped in, we create ingestion points tables. And this is the data model of their JSON in there. Quickly should point out, we do TypeScript and Python. One of the advantages of these is it's usually the really common language that is actually producing the data. So we can generate consumption and ingestion APIs, so you know that like the sender of the data is sending the right data model, which we found to be really helpful.
Sorry, Mike, can you begin a little bit?
Oh yeah, sorry. Everything?
Please.
Yep. Right. There we go. Okay. Cool. So let's do functions next. These sit between two topics and map from one data model to another. And data flows through them, they get run. And finally, we can drop in APIs, which again are just functions, but this is a template string. What it will do is it will rip out whatever is parameterized here, and then assemble a ClickHouse parameterized query, which is great. Like ClickHouse allows us to prevent SQL injection and set up queries in advance. And then, for example, our time series data, we use all these really wonderful ClickHouse functions that we hope to be the main way that users are interacting with their data. It really should just be about like, what you want to do with data transformations, and ideally none of the headaches if you can handle it. So all this is running, so let's run. We have a couple of other fun little, let's get metrics. Yes, we've got consumption, endpoint, streaming, blah, blah. So let's drop in some times. These are served by the consumption endpoint. Refresh it over and over. You'll see these are getting hit and up to date. It's just, we really want the local dev experience to surface to you everything that you want to know. Yeah.
Cool.
So a bit more about ClickHouse because it kind of really ran through that all. The blocks and APIs are where we expect most of the analysis to come from and the value, and that really is all ClickHouse. You're just assembling SQL queries, and one interesting thing that we found is there's all these wonderful functions there, but especially when you're dealing with developers who know they're operating with ClickHouse as the storage layer, but maybe they're not familiar. These can be pretty invisible or hard to, like, I don't know what your guys' experience with this is, how much you're looking at the query docs, but I certainly like trying to figure out what to do, especially blocks, like knowing which merge tree to use. So when we get after this talk, I would love to hear from you guys as far as educating people as far as what to use or what you guys find would be really useful. I'd love to know all about that. So finally, comparison. Yeah, I just want to point out that we were able to create all this infrastructure, defining only 3 things. And it's really just TypeScript model, maybe you want to function, and then consumption for users. We hope to get a lot of people using ClickHouse in a much simpler manner. Any questions? Yeah, go for it.
So your users are writing the SQL queries themselves, or are you guys templatizing the asks, like that big query that you have with the tuples and the arrangement?
Yeah, so maybe it's easier to start with this one. This one, so the general function is, I don't know if you guys can see. Basically, the first is query parameters, so you pass these in the URL.
Yeah.
And then we pass in a client, which has already been configured to hit ClickHouse. And then they would write these, they would write the SQL themselves, create an endpoint over that SQL query. I don't know if you guys are familiar with Tinybird. It's extremely similar to what they do, just as it's open source. We have streaming functions. And then here you can pass in the same thing.
Got it.
I don't know if you guys have used parameter queries in ClickHouse at all. You have to like pass in what the ClickHouse type is and then do it secondary. So it's kind of fun doing the like parsing everything we pass in and figuring out how they are on that event.